Hello students, my name is Sumit Mehta. Today in this lecture, we will cover about miscellaneous examples on circles. In my previous lectures on circles, I covered what are circle and its tangents, what are secants, what are chords, okay, and I proved two or three theorems in my previous lectures about if a tangent is drawn to a circle, then it will touch the circle at a perpendicular point which is perpendicular to radius of the circle. And in another theorem, I covered that if two tangents are drawn to a one circle, then the length of the two tangents will always be equal. So in this lecture, I'll cover some miscellaneous examples based on these two theorems or two properties which we used. Okay, so let me give you one example and how to proceed for these type of examples if the question asked in exams. Let me write the question first. So students, here is the question. This is one of a typical question which might come in the exam, and this is a very tough question from exam point of view. So please be attentive how to proceed this question. Let me first read out the question for you, which states that PQ is a chord of length 8 centimeter. Here is a PQ I have drawn earlier. Okay, it is of 8 centimeter in length of a circle of radius 5 centimeter. Means the length of OP is OP equal radius equal 5 centimeter. Okay, and the tangents at P and Q, the tangents at P and Q intersect each other at point T. So if I can say that TP equal TQ by the use of theorem which I proved earlier in my previous lecture, that the two tangents drawn from a single point at a circle are always equal in length. So by using theorem, okay, now I have to find out the length of TP. So how we will proceed for this question? So students, how we will proceed for this question is, let me join OT first. Okay, so in triangle, and this intersect the PQ at point R. So if I say that in triangle PTQ and triangle RTQ, okay, so I can directly write that TP equal TQ, which I write earlier also by using the theorem. Okay, and this angle, by looking at the diagram, that this will divide. In my previous video or lecture, I told you that this line bisects this angle. If you want to look at this again, you can refer to my previous video also. Okay, so angle PTO equal angle OTQ, okay, which we proved earlier also. I am using this straightforward. So these two triangles are congruent, okay? Or you can say that R bisects side PQ, okay, because QR equal PR. So I can write directly that R bisects side PQ. So in triangle OPR, this angle will be 90, and I know the length of this PQ is 8, so PR will 8 by 2, which is 4. So in triangle OPR, 5 square minus 4 square is equals to OR square. So we will get the value of OR as 3 centimeter. Okay, after getting the value of OR, how we will proceed? We have to find out the value of PT. So I'll do this question in two ways. First, let me tell you the first way. I'll apply the Pythagoras theorem. Let me delete some part. So I can assume that if I have to find out the value of TP as x and TR as y, and in triangle TPR, so this is perpendicular, so x square equal y square plus 16, and in another triangle which is PTO, by applying the Pythagoras theorem, PTO, because this angle is 90 degree. Tangent always cuts the radius at 90 degree. In triangle PTO, I can say that PT square, which is x square plus 5 square, is equals to OT square. OT, I can say that if I don't know the value of TR, which I assumed y plus 3, because y is TR and OR is 3. So I can use these two equations to find out the value of x and y. What I'll do here is I'll put the value of x in terms of y. Y square plus 16 plus 5 square equal y square plus 9 plus 6y. So y square cancel out. So 25 plus 16, 41 minus 9 is 6y. So I'm getting the value of y as 32 by 6, so which is 16 by 3. So putting the value of this y in equation 1 again, I will get the value of x. This will be 16 plus 16 by 3 whole square, x square equal 16 plus 256 by 9. So what I will get, 16 into 9 is 144 plus 256 upon 9. This comes out to be 400 by 9. So it is 20 by 3. So it's coming out to be 20 by 3. So which we have to find out. So I know now the value of TP, which we have to find out. Students, please note, keep this in mind that this is one of the typical questions which might come in exams, and you can use Pythagoras theorem or the properties which I state earlier also. So by using these two methods, one is Pythagoras theorem or one is the property that the tangent will always cut the radius at 90 degree or perpendicular, and the two tangents will always be equal if they are drawn from one particular point. Okay, so please keep that in mind, and if you have still any query or any issue on these type of questions, please do comment in the comment section, guys. I'll be happy to help there. Thank you.